1, 2, 3, 4, 5. The electron is present here. A photon is incident on it. Or actually on an atom, it is. We should not show like this. A photon is incident. What is the wavelength of photon? 975 angstroms. It'll get excited. It's saying it'll absorb. It'll get excited. How many different lines? Hydrogen atom. See, one atom possible? No, it should be hydrogen gas only. Though in question, if you get like this hydrogen atom, still what happen? You have to treat like as if like a gas, like in container, hydrogen gas is filled up, and I cannot can I isolate one photon? Not possible, no. Radiation is radiation. So there I'm going to take a light of wavelength 975 electromagnetic wave of 975 Armstrongs. I'm going to pass through a container in which hydrogen gas is filled up. Then I'm going to see the radiation, not of one photon interacting with one atom. I think that is a totally not possible. There's, I think, nothing to do with here. So you have to stick on to the basic. First, what is that energy of photon? See, not only, even for me also, if I get a question, I should do calculation. There's no other way. Now, what is the energy of incident photon? I'll straight away jump into the calculation part. 6.62 into 10 to the power of minus 34.
Directly 12,400 we can write now.
Or HC value?
12,431.
If he doesn't mention, check it. It's approximate, no? I think we have to be very, very alert. And we want everything in electron volt. The lambda is in Armstrongs, no? So after getting this answer, divided by electron, charge of electron. So this I'll multiply charge of electron. So our answers will come in electron volt. Now I can get into problem. So I am bringing this problem specifically to tell you that you can't write SC some value. If he mentions, you mention SC value. If he mentions like a 12,300, 12,340 sometimes, okay, take it that, what he mentioned. If he doesn't mention anything, you must substitute these values. Then you have to conclude here. Check, if you take 12,300, you will get different answer. Intentionally is asked here. If he mentions some SC value, what values he mentioned, that you substitute. If he doesn't mention, you should substitute the original values of HNC and work out here. 12.5. I think you have some idea of 13.6 minus 3.4. I think the better, if you remember the energies, you'll be on safer side. You must practice this particular thing. Up to till 5 levels, if you remember, you are on safer side. Up to at least if you directly know this, otherwise you have to calculate in exam. You see that this is all about the very simplest things. If you know these values, directly put it. Now the item is that it will make a transition so that this much of energy difference will come. To which state it can jump. Anybody, any equal to 5 value? 0.53, no, it seems.
54.
0.54, no? Now, where do it will make a transition? Definitely open this particular will make a transition from this what, and in the in turn what happen, will get a wavelength. So these are the wavelengths. Calculate the longest wavelength among them. This should be the longest. And this should be the shortest, that one. So here longest wavelength will be lambda 43. It's very simple, no? So I think the intentionally what happened, you write some value, what in some books they give 12,000, sometimes they'll give 12,300, some books they give 12,340. So students are assuming that, and they're getting disturbed here. 18807 Armstrongs. Check calculations later on. I'll go to the next part. There's a very best question. A very nice concept is involved. Please first do read.